Welcome to this webinar concerning SIP-I. Ashley, can you get us started, please?
Thank you, Mark. Hello. Thank you for joining the webinar today on SIP-I. I'm Ashley with Pulse Supply, and also joining me today is Mark St. Onge with Telcobridges. Today our discussion will focus on interworking ISUP and SIP components. During the presentation, if you have questions, feel free to type them into the GoToWebinar control panel. We'll read them aloud and respond as we go. If we've moved to a different slide or we miss your question, there will also be a chance at the end of the presentation to ask questions. So let's get started. Today, we'll provide a brief introduction of our companies. We'll talk about SIP-I, what it is and why it's used. We'll also talk about the differences between SIP-I and SIP-T and when to use SIP-I. Then we'll show you some specific application examples. And finally, we'll talk about Telcobridges products and where they fit. For those of you who may not be familiar with Pulse Supply, we were founded in 1995 as a distributor of connectivity products, and by the late 90s, we began providing TDM to IP conversion products for our clients, who are typically carriers, large enterprises, and other service providers. Telcobridges is one of our key partners in this area, and we've been solving network challenges with their products since about 2008. Our goal today is to provide information to you that will be helpful and offer solution ideas that allow new technology that is available to operate with the infrastructure you already have, helping you stay within budget. If you'd like more information about Pulse, our background or capabilities, I can provide that at the end or follow up after the call. But for now, I'd like to hand the presentation over to Mark with Telcobridges. Mark?
Yes, thank you, Ashley. Thank you for the introduction. My name is Mark St. Onge. I'm responsible for sales support at Telcobridges. I've been with the company the last 7 years of its now more than 10-year history. We're a Canadian-based company. We're a manufacturer of telecoms, telecommunications equipment, specifically voice-over IP gateways and telecom platforms for carriers. We design our own hardware, perform all software development in-house, as well as perform production and testing at our company headquarters in Montreal. We provide technical support to our customers 24 hours by 7 days from our head office, once again located in Montreal, Canada. This webinar, which will last approximately 30 minutes, concerns SIP-I, what it is, when to use it. I'll be providing some applications, sample applications, and a brief overview of our products at the end. Like Ashley said, if you have questions, please type them into the control panel of the GoToWebinar. If we see questions during the presentation and we're able to answer them right away, we will. Otherwise, we'll answer all of the questions at the end. And we like questions, so don't hesitate to type in your questions there. So let's start right away. What is SIP-I? Well, in fact, SIP-I stands for SIP with encapsulated ISUP. And it's basically, in a nutshell, a way to transport ISUP messages over SIP networks. It's actually precisely the encapsulation of a copy of an ISUP message directly into a SIP message. This is useful when we bridge calls between traditional SS7 TDM networks and the next generation voice over IP networks that use SIP signaling. So the standard that defines SIP-I is an ITU standard. The relevant standard is seen on this slide at the bottom. It's Q1912.5. It's also been picked up by other standards bodies, and I'll show you those a little bit later, and I'll discuss about SIP-T. But basically what SIP-I defines is a way to carry ISUP messages within SIP messages, but the standard doesn't only do that as well. It also specifies a specific mapping between SS7 ISUP messages, such as IAMs, an initial address message, or an ACM address complete message, or a release message. It specifically defines how these ISUP messages map to SIP messages, and of course it specifically defines how to actually insert the ISUP message within SIP. It's really not a difficult protocol to understand, and I hope with this presentation you'll be able, you'll know just about everything you need to know about SIP-I. Well, why do we have SIP-I? Well, for many reasons, but the main reason is that SS7 networks and SIP networks are not designed or are not created with the same philosophy. Traditional SS7, a traditional TDM network that uses SS7 has all of the intelligence in the core of the network. All of the services that are available for us as subscribers of, let's say, traditional telephone network, all of these services are provided by the switch, and our telephones are, in fact, I could say dumb devices which are able to deliver us the services, but they all come from the centralized switch. Whereas SIP was designed as a protocol which would enable intelligent terminal devices or intelligent remote devices to communicate together, to establish sessions between each other or calls between each other, and using a core network which is as transparent as possible and in a way simply provides bandwidth or the capacity to handle these sessions that are set up between intelligent terminals. So the two protocols, or the two networks, in fact, the SS7 network and a SIP network, are really not designed the same way. And when you bridge between the two, well, either there is some information that is lost when you actually perform the bridge between the two networks. Some ISUP features, for example, are lost when we bridge calls to a SIP network. Some SS7 call flows or some specific ISUP messages don't map well into the SIP protocol, so sometimes it's difficult to replicate specific SS7 call flow or deliver exactly the same service on a SIP network as you can do on an SS7 network. So SIP-I was created to solve those issues, and it was created to solve these issues in a very simple way, and that is plainly that a copy of SS7 ISUP messages that are received, for example, at a voice over IP gateway will just simply be encapsulated into the SIP protocol. But like I mentioned, the standards do specify more than that, but that's the basic idea when it comes to SIP-I. Should say something here about SIP-T, which is just about the same thing as SIP-I. SIP-T stands for SIP for telephones, whereas SIP-I stands for SIP with encapsulated ISUP. SIP-T was the first protocol that was defined by, well, the first SS7 to SIP interworking protocol that was defined by the IETF. It was picked up later on by the ITU to create SIP-I. There's only very slight differences between SIP-I and SIP-T. SIP-T was defined with the purpose of being able to provide the ISUP information to voice over IP endpoints, let's say SIP phones, for example. Whereas the SIP-I protocol instead had in mind the ability to voice over IP gateways or PSTN gateways, and with the objective to provide the ability to have better interworking between SS7 and SIP for telecom networks. Out of these two different standards or specifications, which in fact specify just about exactly the same thing except for some very small differences, the SIP-I specification is much more precise. The information is much more complete than it is in the SIP-T RFC. There's not, for example, a specific list of RFCs to be supported. Instead, in the SIP-T RFC, it's more inferred which RFCs should be used. Whereas the SIP-I standards is very precise, and that's why it's more widely adopted than SIP-T. But in fact, they both aim to solve the same issue, and they both do it just about exactly the same way, except for some slight differences. Our gateways, Telcobridges gateways, support both SIP-I and SIP-T. I told you that the SIP-I specification was produced by the ITU and that it was quickly adopted just worldwide, in fact, where you see the specification being adopted by ETSI, by ANSI for North America, the United Kingdom, Finland, and finally also in mobile networks where it was adopted by 3GPP, or the Third Generation Partnership Project, as the SIP protocol to use in mobile networks, or recommended to be used in next generation mobile networks. So SIP-I is widely used, and I've told you the purpose of SIP-I is in fact to be able to transport SS7 ISUP information over SIP networks such that SS7 features don't get lost, and that SS7 networks on either side of voice over IP network can have access to each other network's information. Let me present you here three applications or three examples where SIP-I can come in handy and where it can be an advantage. So my first example or application here is the simple interconnection of two SS7 networks over a voice over IP network. So what I'm showing here on this slide is two, I guess we could say, traditional TDM carriers, carrier 1, carrier 2, who are interconnected via voice over IP network. To achieve this interconnection, voice over IP gateways are used. Our gateways are shown here, where they interface using SS7 signaling to each of these carriers, and use SIP, or the voice over IP network, to interconnect the two together. And this voice over IP network in this example is controlled by a soft switch. So what we're doing here to transparently carry the SS7 ISUP information between carrier 1 and carrier 2 is we're using SIP-I. So we're using SIP to be able to perform the call control here over the voice over IP network, but we're also using it as a way to transport the ISUP information between carrier 1 and carrier 2. And it's interesting to be able to do that because, as I mentioned earlier, there are some SS7 features that get lost or don't map well to a plain SIP protocol, and I can give you an example. In an SS7 ISUP, there is an information element or a parameter called the calling party category. So when a call is established on an SS7 network, the first message to be sent is an initial address message, or an IAM, and it includes, of course, the calling telephone number, the called telephone number, but it also includes an information element that's called the calling party category. And in this calling party category, it's specified a few things, but one of the things that is specified is the origin, or the type of the originator of the call, and this can be an ordinary subscriber, for example. It can be an operator that's initiating the call. It can be a priority caller, like the police, for example, or others. I think there's also something like a phone booth, mobile, and so on. It's interesting to be able to transport this calling party category information between SS7 networks, because in the receiving network, the network can use that information to handle the call differently. So, for example, in the receiving network, the call may be intended to a subscriber which is using the do not disturb feature, or is using the anonymous call blocking feature, where the subscriber refuses to receive calls without caller ID, or that is not within a selected list of callers. But in fact, if the call that's intended for this callee is in fact a call that's established by the police, so in fact a priority call indicated by the calling party category, while the receiving network may want to ignore the do not disturb request by the subscriber, or the anonymous call blocking to in fact establish the call with the caller, because it is an emergency call or something like this. And this calling party category is not always well mapped to traditional SIP or ordinary SIP messages, although there is a way. It's between vendors, it's possibly not always done the same way, or as the call traverses the voice over IP network, well, the calling party category information may be lost. So the best way to ensure that the ISUP information from the originating network reaches the terminating network is to actually encapsulate all of this SS7 information directly into SIP messages as another body within the SIP message, and so the receiving network can act on this ISUP information. So that gives you an idea of why it can be interesting to use SIP-I in a network such as this one, and specifically, it's simply to transparently carry the information from one SS7 network to another in this case. In this second example that I'd like to present to you, I'm showing here an inter-exchange carrier that is connecting to three TDM carriers, or three traditional carriers with which, for which the interconnection is via SS7. So each of these carriers, 1, 2, and 3, have SS7 links via a voice over IP gateway to the inter-exchange carrier. The inter-exchange carrier has a SIP-based network, or a voice over IP network. It's using class 4 soft switch program to perform the call routing and generate the call detail records and so on. The use of SIP-I here for an inter-exchange carrier actually not only allows for the transportation of ISUP from carrier to carrier, but if the soft switch is capable of processing ISUP, SS7 ISUP, well, this carrier, this soft switch can actually manipulate the ISUP information between these carriers before, let's say, an incoming call from carrier 1 needs to be routed and established with carrier 2. Some parameters that may be manipulated or changed by this soft switch may be the nature of address, for example, changing an international nature of address to national or local or something like that. So it's SIP-I can be used to do exactly this. Once again, if ordinary SIP was used for something like this, then possibly some SS7 ISUP information would be lost when the inter-exchange carrier is establishing calls between these 3 carriers. And what's more is that, well, if the soft switch is capable, then the ISUP layer can be modified to adapt to different requirements. And then finally, the third application that I'd like to present here is one that concerns an international long-distance carrier. And what I'm doing here is showing an international network where many types of networks are interconnected using different protocols. And what I want to do is explain how SIP-I can bring some uniformity and some compatibility or some additional compatibility between all of these networks. So I'm showing here a country A on the left side, country B on the right side. In both countries there are 3 types of network: a voice over IP network that's interconnected with the international long distance carrier in the center there using SIP, ordinary SIP protocol. There's a mobile carrier in each country as well, and in this case the interconnection with what I'm showing here, that Telcobridges Gateway is using SIGTRAN, which is simply the SS7 transport over IP. It's actually an SS7 interconnection, but instead of being on traditional TDM links, it's over IP. And finally, let's say a fixed line TDM carrier where the connection via the voice over IP gateway here is using SS7 with each of these carriers here are providing a certain number of bearer channels for interconnection with the long-distance carrier. And then, well, similarly then on the right side, it's the same setup, except I'm just showing that the gateway here can be controlled via H.248 by the international long-distance carrier using H.248, and the SS7 signaling is relayed using SIGTRAN. And you have in the center here SIP-I, SIP with encapsulated ISUP. The idea here again is that you can transport ISUP information from country A to country B, the calling party category, redirecting numbers as well. All of the information that traditional SS7 network carries can be easily carried from network to network over SIP-I. Notice here that I'm showing on the left here that the gateway is interconnecting with ordinary SIP to the voice over IP network in country A, and it's interconnecting with SIP-I with the soft switch. If the gateway is capable of doing this, like Telcobridges gateways are, the gateway's role here is actually to use ordinary SIP with the voice over IP network and to actually build the ISUP message in order for it to be sent using SIP-I towards the soft switch. So Telcobridges gateways are capable of doing this, taking the information that's received on a, let's say, a SIP invite, calling number, called number, caller ID presentation, and so on. The gateway is capable of actually building an ISUP message and then encapsulating it in SIP in order to process the call and establish the outgoing leg of this call. And the purpose of SIP-I here, well, as it says on the bottom here, is to be able to achieve complete compatibility, or at least to increase the compatibility and be able to transport as much information as possible between the networks in country A and country B, and this is the purpose of SIP-I in such a network. If ordinary SIP was used, well, there could be some SS7 information elements or some ISUP information that will be lost along the way. Now, in this portion of the webinar, I'd like to just briefly present a couple slides on Telcobridges gateways and then give you a configuration example. What we do here at Telcobridges is provide voice over IP gateways. They're available with different port densities, from simply single T1 or up to more than 1,000 T1s, with also DS3 interfaces, OC3 interfaces. These are carrier-grade voice over IP gateways. They are designed for carriers and not for enterprise networks due to the protocols that are supported, due to their high availability architecture and their redundancy. In this slide here, I show, well, at the top of the table here, the signaling protocols that are supported. Of course, SS7, SIGTRAN, SIP, SIP-I, SIP-T, but also ISDN, PRI, T1 CAS, CAS-R2. The gateways are configured and managed using a web-based interface, and they also support SNMP to tie into your network management system. And all of the gateways provide exactly the same features in terms of software, except some slight differences here at the bottom that concern, in the last two rows, announcements and call recording, as well as the number of calls per second. Speaking of configuration of the gateways, I will just show you here in these next two slides how SIP-I is enabled in a Telcobridges gateway. This is a screenshot of the web-based interface, and as you can see, it's very simple. There's an enable checkbox, which you check if you want to enable SIP-I on for a specific SIP destination, and then the only thing you need to do is to select the ISUP variant that you want to use on this with this SIP destination. And I show here the different ISUP variants that are supported. In the USA, we're concerned here by the ANSI variants, the first three at the top of the list, and the Telcordia ISUP variant. But all of these other ISUP variants are supported as well. And as I mentioned to you, it's actually quite easy for a gateway to implement SIP-I. The gateway simply has to have the ability to take the incoming ISUP information and encapsulate it into a SIP message. Also, you do have to conform to the specification, which specifies specific mappings between ISUP messages and SIP messages. And the other aspect also is that if the gateway may have to be able to manipulate some ISUP information elements, or actually generate the ISUP message to be inserted into the SIP message, and that is what our gateways are capable of doing. So finally, in summary, before I have a look at some of the questions that we have and answer some of these, would just like to summarize that the use of SIP-I and SIP-T, which are just about identical protocols, is very simply to transparently carry ISUP information across voice over IP networks. The goal is to avoid losing SS7 information when you bridge calls to a voice over IP network. So SIP-I provides a way of carrying that information from one end to the other transparently. And it allows to bridge SS7 networks over voice over IP networks in a seamless fashion where all of the information is transported from one network to the other, and then each network can then do what it should do with the ISUP information that's received. So I'd like to thank you for your attention. Looking at the time here, I see that about 30 minutes have gone by. If you would like more information, there are two contacts here on this slide, Mr. Bobby Bain with Pulse Supply, as well as myself at Telcobridges. Please don't hesitate to reach out to us if you require some more information. Let me have a quick look here at some questions before and answer some of these questions before we end the webinar. The first question that I see here is, what happens when a SIP device does not support SIP-I? Will it ignore SIP-I fields? Well, the answer is yes, it will ignore SIP-I fields. So we can say that SIP-I is in a way backward compatible to ordinary SIP. Recall that the mapping of SS7 ISUP messages to SIP messages is specified in the SIP-I standard. So those SIP messages are standard SIP messages and normally understood by all SIP devices. The ISUP information that's encapsulated into the SIP message is actually just another body inserted into the SIP messages, and devices that do not support SIP-I just simply ignore that part of the SIP message. So there's no and absolutely no interoperability issue between SIP-I devices and ordinary SIP devices. Let's see, another question here. Is SIP-I the same as SIGTRAN? The answer is no. SIP-I is not the same as SIGTRAN. The two protocols are actually quite different, although they both, in the end, achieve the transmission of ISUP information over an IP network. But the differences between the two protocols are the following, is that SIP or SIP-I is a call control protocol, which actually, its purpose is to actually establish sessions, and in the case of voice communications, its purpose is to establish voice calls, whereas the SIGTRAN protocol is just a transport protocol. It's not a call control protocol. Its purpose is not to establish calls. Its purpose is to transport SS7 messages over an IP network. So it defines a specific way to use IP with a specific layer 4 protocol to transport SS7 over that IP network. So they're not the same thing, and they're not equivalent. Here's another question. Just a moment here. Okay, here's a question. Can ported numbers be routed using SIP-I to tie into local number portability devices? I think the answer here is no, because there are really two ways that are commonly used to dip or to query local number portability databases, and that is using an SS7 connection to perform the query into the database, but that SS7 connection uses TCAP. It does not use ISUP, and SIP-I is specifically for the transport of ISUP within SIP messages. There's another way, though, to query a local number portability database, and that is to use SIP, or ordinary SIP, but not specifically SIP-I. But I suppose that if you're using SIP to query an LNP database, and all of a sudden you would send a SIP-I message instead, I think the LNP database would just ignore the ISUP part. But it doesn't provide any added benefit to use SIP-I to support local number portability. Here is a question. What RFC controls SIP-I? Is RFC 3261 used? Well, in fact, SIP-I is defined by the ITU. If I can come back quickly to this slide, which I had here, or maybe the previous one, you see here on the left that SIP-I is defined by the ITU, and it's been adopted by ANSI. SIP-T is defined by the IETF in an RFC, and I have to say I apologize, I don't remember the RFC number exactly, but there are only very slight differences between SIP-I and SIP-T, and I mentioned earlier in the presentation that SIP-I was say more precisely defined. It left it leaves less room for error, and therefore a better results in interoperability testing than when it comes to SIP-T. Well, I think that's it. Ashley, I'd like to say thank you once again to everyone for attending. Thank you for your questions, and I hope you found the webinar was informative. Ashley, can you end the webinar, please?
Yes, thank you again for attending. The webinar can be found on our website later. It will be posted, so if anyone wants to go back and take a look at it, you can do so there. And contact Bobby Bain if you have any questions. Thank you.